Okay, so helper method. I'll switch to Eclipse and iPad in a moment, but you can go back to your review slides that we started yesterday in class. You can go to slide 62, right? In case you wonder if there's an easy way to navigate, you can always click on this logo over here on the slides, and there's a hyperlink all over. And that's towards the end. You will see helper method over here starting from 1. So what I would do is I'm just going to go over one single slide about the principle of the helper method, why we may want to do it. And then there are 3 examples mentioned in the slides. I will do one with you in the morning. I will do another one in the afternoon. So for you guys, you can feel free to refer to just that part in the afternoon as well for the second example. And what about the third example? Exercise. But you can also find a solution on the slides as well. So you got 3. Okay. So let's go over some principle quickly, and then I will show you how you can do the exercise, to import a project, which I'm going to make available later today, and also you can try it out from there. But it's important to see why we want to do helper method. So after you have completed and tested your program, feeling confident is correct, it might be it. However, you might be a perfectionist, so you really want to make sure the code structure in your Java project is as efficient as possible. So here, when I say efficient, I don't necessarily mean it runs faster. I'm talking about the structure of your code is such that it's more maintainable. Especially, we want to make sure there are as few repetitions as possible. When I say repetition, you might have found that maybe even your first year, you may have to keep writing the same block of code throughout your projects, maybe for 5 times or 6 times. Whenever you see such occurrence, that's an indication you may want to create a helper method for making your code structurally more efficient. And there's a way people say that informally. If we do see repetitions in your code over and over again, we say your code smells. So what you really want to do, what we want to do today is to get rid of the smell. Let's say in this first example. Okay. And so we want to eliminate repetitions in your code by, so now we call factoring out. Okay, so think analogy over here. Let's say if you got mathematical equation, let's say you got x times y plus x times z. Factoring out simply means we got 2 occurrences of x over here. Why don't we simply do x and then y plus z? That's really what I meant by factoring out, mathematical way. But when we do programming, hopefully that's even more intuitive. We want to get rid of repetition. We want to have the occurrence of x over here rather than 2 to become 1. That's what we want to achieve. Right? Let me go back to the slides. So we want to factoring out, and we want to create a new method. And then it's called a helper method. And you want to make sure every occurrence of the repetition, rather than repeating the code verbatim, you want to replace that by some helper method call. That's what we'll see. That's the principle. And so you can reuse it whenever you want to, even for future use. Whenever you think this particular helper method can be used, you can just call that rather than repeating the code. And it's called refactoring. So remember I mentioned about refactoring yesterday in class. In general, refactoring simply means you want to change somehow your code, its structure. You may do renaming, you may do renaming of your class, renaming of your attributes, or creating helper method. But all of them should really you want to make sure that your code still remain correct. So let me just do a final sketch, and then we'll get to the specific example. This is what you want to think about. Let's say this is your version number 1. Version number 1 of your Java code. And for version number 1, you found that it smells, meaning that it contains repetition. Okay, but let's say at the moment, you have already run some Java, like a JUnit test case. Let's say at the moment, you actually got some JUnit test cases. So JUnit test cases, let's say it passed. Even though the code smells, but it's correct because you get a green bar from the JUnit test cases. But what we want to do is to improve the internal structure of your Java code to make sure it doesn't smell, number 1, and number 2, it's still correct. So what we'll do is we're going to do some refactoring over here. So we're going to say refactor. And then we can evolve into version number 2 of your Java code. So version number 2 of your Java code, specifically, it doesn't smell anymore because we got helper methods. And at this point, it doesn't smell anymore. But you got to make sure the refactoring does not impact the correctness of your code. So you will have to rerun this new version against the set of test cases and make sure it is still correct. That's the process we're doing. So for the specific example we're going to do, I'm going to show you version number 1 to let you pause a little bit to really appreciate yourself why it smells. And then we're going to build maybe just build a single JUnit test case together, just to illustrate the point. And then I'm going to show to you how you can go from here to here. After we have done that, we're going to run the same test case we built and make sure it still passes. That's the workflow we're going to go for. And this is really the workflow you also want to practice yourself. Every time you have version number 1 working, don't be too satisfied just yet. You want to be critical on the code structure of your code. If you got repetition, try to factor them out into helper method and make sure the new version is still working. All right? Okay, let's now look at the first example. The first example here requires a little bit knowledge about part 2. But let's just read over the code. It uses array, uses some reference attributes. So for now, let me just focus more just on the code structure, right? And then for the code tracing, in the interest of time, let's not do any tracing. I'll do more tracing on this particular example in the part 2 video and also maybe sometime in class. But let's focus just on the code. Okay? So now this will be the class to start with. How about I just go over that quickly? Okay, let's start with this. So that's the class we got. So we have a class called PersonCollector. It's going to be a template for collecting different persons. So that's why you will see we got some person array over here, right? It's an array. And every time you have an array of some reference attributes, you will need an integer counter to keep track. So without explaining this logic too much, you will learn about it thoroughly in part 2 of the lab 0. For now, let me focus more just on the code. So these are the attributes that we have for this particular class. No repetition just yet. And we have a constructor over here, which will just initialize the array. And we got another mutator over here for us to add person. So once you get to lab 0 part 2, I want you to pay special attention to why we are doing these 2 lines. I explained there in much detail. Okay, for now, let's not worry. So far, this PersonCollector class is fine. No smell, no repetition. What I want you to look at now is, we are now trying to define number 1, number 2, and number 3. We are defining 3 methods over here. I will let you take 1 minute to look at the code over here. Without worrying too much about what these codes are really supposed to do, assume that it is correct. But I want you to look at the structure. Can you spot repetitions? That's my main question for you. Take a look for 1 minute, and then I'll highlight it to you, and I'll show you how we can fix it by using helper method.
I cannot see this.
Oh, you cannot see? Sorry. Sorry about that. Okay, another 30 seconds. If you already got your answer, keep it, and then I'm going to go over. Okay, 10 more seconds. Alrighty. Let's now take a look. Well, I would say this code smells quite badly because it has certain repetition for 3 times. Let's highlight that. You can see over here, we got this particular for loop header repeating 3 times. And also we got to do this particular conditional check 3 times as well. So these are the repetitions. right? But this version number 1 here actually works. Okay, so why it works? Let's now just go back to the Eclipse. I'll show you how to develop one JUnit test case. It's good to refresh up your mind about how to do JUnits. And then I'm going to come back here and show you how we can factor these out into a helper method. And we're going to do it. Okay, so later today, I'm going to make a zip file for you to download from the study sites. But I'll show you how you can import it. Haven't uploaded yet, but I'll show you. So once you got the zip file, once you got a zip file downloaded to your machine, you can just go to Eclipse, File, and then, you can say File, Import. And then under General, Existing Projects. And then make sure you say Select Archive File, Zip File, and browse to where you store that, let's say on the desktop, right? If you select that, so this is the starting project for you, and finish. And then if you expand it, you will actually see there is, under helper methods, we actually got, let's say, PersonCollector over here. Right? So this is the method you guys just look at. Right? That's the one. Okay? One thing I'm going to do. This is where we are. So we have just look at version number 1. But now let's make sure it works. I'll just do one simple test. Okay? Just one simple one. So just to show you how you can develop JUnit test case. So we can say right-click, New, JUnit test case. And JUnit 4, let's say Test PersonCollector. Okay? And then, let's say just test. So now let me just choose one of them. So let's say we want to create an empty PersonCollector. Let's say we want to add a new person over there. And then we want to ask whether that person exists. As easy as that. How about that? Okay? So what I will do is I'm going to go to the test PersonCollector. So let's say, PersonCollector. Yeah, make sure you type correctly. And then Control Space is going to allow you to import it from a different package. Right? Choose that. So let's say PersonCollector, New PersonCollector constructor. This will create an empty one. Let's add a single person. So let me do some check right away. If I say assert false, and I say PC.person exist, for example, does Jackie exist? Should be false. It's empty. On the other hand, if I say PC.addPerson, Jackie, and now, let me just see what's wrong there. So if you go back there and see PersonCollector, it is expecting I see a person. So let me do it again. So go back there, and then I can say person Jackie equals new person. And let me just remind myself, in the person class, you got the constructor over here. You got to pass the age, weights, and heights, whatever, right? Just for illustration, I'll say it's age, weights, and heights. Doesn't matter. Okay? Okay, let me see. So the person here, did I pass the wrong information? Int double. Okay, let's see. Let's see what error I got here. Oh, actually, I need to import it. So if you move your mouse over the person, you got to make sure you import it. All right? Okay, it's good. And then I'm going to add this person object into it. And this is something you will do in part 2 of your lab 0. And now, after this, I'm going to copy this case over here. And then I'm going to say assert true. Okay, you can see what this test is doing, right? I'm just testing the correctness of one method. And then I'm going to run this. Okay, it's now running. Somehow I got some error here, null pointer exception. Just give me one moment to see what's wrong here. let me try to fix this a bit, but this one is supposed to be a green bar to make sure it's correct. I'll fix it. Let's not waste time. So assuming that this is, the code is correct, I'll fix it before I post it. But let's now move on to just defining the helper method, and then we'll come back. Okay? I'll check and then make sure I post the correct version. But the point is you want to define a test, as many tests as you can, to really test the correctness. And now let's go back to the person collector. Okay? What we saw before was we got these repetitions. 1 here, 2 here, and 3 here. So what should we do over here? The idea would be we would like to have a standalone helper method that is going to allow us to really go over all the collections in this way, and then go one by one. And once we get to the particular one that has the name, matching the name we are looking for, in that way, we want to know where we are in the index. So that's the helper method we're going to define. Okay? 1, 2, and 3. Let me do that. So the way to do it would be, let's now just go back to the helper method here, copy it, and paste it. Let's say person collector improved. Of course, you may just directly modify this particular method, this class, to make it improve. But I'll just show you the two versions over here. So over here, so this will be the improved version with helper method. And the helper method we'll need is, I'm going to put it here. So, well, for helper method, it's kind of up to your decision, but typically, helper method will be more internal to your code. So you may not want to declare them as public. You might want to make them private. So for your later lab submission, we don't really check public or private, but it's a better practice if you simply make your helper method private. Okay? So let me say private. And then it's going to be returning some integer, meaning that we're going to go over the collection this way over here, one by one, until we get to the one that's going to be equal to the name we're looking for. That's what we're achieving. And then once we got the helper method done, we can reuse it for every occurrence over here. So that's the plan. Let me do that quickly. So private int, let's say index of. So let me put a comment here. Go over the collection of persons, return the index where the matching person is stored. Okay, that's the index of. And then we know that every time we need to compare against some string name over here. So let's take a string parameter. So we'll say string n over here. Right? So let me just go back to the pool version. You can see these are the repetition, for example, over here. So why don't we simply copy this, and then I'm going to play with it. So I'll go back here, and then I will declare some integer over here, let's say index. Let's say initially it's simply just -1. -1 means we simply, if we cannot find a particular name, it will just be -1, which is an invalid index. If we can find it, it should be 0 or up to the length of the array, -1. Right? And then for this part here, that was part of the repetition. We keep it, and this one we also keep it, right? So this is where we can have a single place to store things for reusing. And then here, once we have found it, we can say the index is equal to just I. And ultimately, we can say return index. So this is a very valuable refactoring we have just done. So this is going to be reused in every occasion where you want to go over the collection of persons. Okay? So now let's do the following. Okay? So now this is the repetition where we want to find out if the person exists. So the logic would be, let's call the helper method to find out where the person is. If the index return is -1, we should return false because the person doesn't exist. If the index is not -1, that means it exists. Okay. So what we'll do is, as easy as get rid of the repetition for this one here, we can simply say, or even I'll give you the simplest version. You can say return. I'm just going to call the helper method index of, and if it is larger than or equal to 0, that means the person exists. All right, so now let me show you on the iPad. What used to be this has now been improved into this. All right, let me do another one. Yeah, if you kind of somehow follow the workflow, that's very good. So that's why I'm also recording this. You may really want to dive into more into the logic alongside with part 2, so to really appreciate what the helper method can do for you. Let me finish the other two, and then we are done. Okay. What about this guy here? This guy is pretty much similar. We want to still find out where the person is, and we want to set its weights. Okay, so this is where some difference might occur. So let me just cut that, put it here. And then I want to call the helper method again. Integer index is equal to index of, and then that person. So I want to find out this person. If the person exists, I should be able to set their weights to be something else. If they don't exist, I don't do anything. So I might say here, if the index is larger than or equal to 0, following the similar logic here, if the person exists, right? If that's larger than or equal to 0, in that way we can set the weights. And now rather than I, we can say index. Right? So we got rid of the repetition for this method here by calling the helper method. Right? One more, and then I'll do a conclusion. And for this one here, very similar, except that it's now to set the heights rather than setting the weights. So why don't we do some copy here? So now, so here you can see we're still calling the helper method here, but now we're going to set the heights. Right, so that will do it. Final conclusion here. You want to remember the general workflow for helper method. We got version 1, which may contain repetition, is completely natural. But before you go on to version number 2, you want to make sure version number 1 passed all the JUnit test cases. I'll make sure the one I post to you will be the correct version, but it should be a green bar. And then you will refactor the way I did just in the past 10 minutes and make sure the version number 2, once it's done with the helper method, also will pass the test cases. And when you look at the notes, really compare this version here with without the helper methods and this version here with the helper methods. And as for exactly how to trace such code, once you follow through part 2 of lab 0, you will be able to trace as well. All right? So guys, any question? Yes?
I think version 1 and 2 would work slightly different if we have 2 persons with the same names.
Oh, so yeah, so good question. The question was, what if 2 persons have the same name? You can think about what we're doing here is more like a dictionary. When you have dictionary, so every word in the dictionary should be unique. So over here, we are, of course, kind of assuming that each person we store in the person collector should be a different name. Or we can make it maybe like an ID collector, in which case ID number should be unique, right? Otherwise, of course, you might get some inconsistency. That's not what we are worried here. Good. All right, guys, thank you. I'm going to post this later today. And what exercise can you do? All right, once I post it, in the afternoon, I'm going to do another demo. The same principle is going to be explained, but I will do another one for points. That's what I will do. So you can feel free to refer to that part of the recording for the point. And then the example you can do is a class called students. I want you to look at the student class over here, and then identify the smell, and try to create an improved version of the students, and try to create a helper method. Try to do that yourself first, and then you can find a solution on the slides. All right, thank you. And then continue with your work, please.